4.1, congruent figures. Now you remember that congruent means the same or equal. And the objective of this lesson is to recognize congruent figures and their corresponding parts. Now hopefully you remember that corresponding means same position. We are going to use the corresponding parts and compare them to determine if our figures are congruent. So one thing to remember here is congruent figures have the same size and the same shape. So they're going to have the same angles and the same sides. Now, congruent figures don't always have to be sitting in the exact same order next to each other. We can take a figure and slide it over onto another figure. We can take our figure and actually pick it up and flip it over and have it be the same as the other figure, or we can also rotate our figures. So you may have to turn your paper occasionally, or look at these kind of carefully to see that they are congruent. So let's see how this goes. Congruent figures. This is going to be one of our definitions. This is the definition of congruent polygons. Congruent polygons have congruent corresponding parts. That means that sides have equal, we need to be more accurate than that. Corresponding sides have equal length and corresponding angles have equal measure. Now you should say, hey, I've heard that before. That's our definition of congruence. Sides have equal length and angles have equal measure. Important here is when you name congruent polygons, you must list the corresponding vertices in the same order. Order matters. And so when we write a congruence statement, this right here is called a congruence statement. When we write a congruence statement, your corresponding parts have to be in the same position, right? Corresponding means same position. So let's take a look at what that means. We have quadrilateral ABCD, and it is congruent to quadrilateral EFGH. And so what we are looking at here is, if we look at this and it's position 1, 2, 3, 4, right? This is in position 1, 2, 3, 4. We can use that to mark congruent sides or to list our congruent sides. So let's look at side, what's our first side on our first quadrilateral, or our first quadrilateral? Side AB, right? That's position 1 to position 2. So there's side AB. Well, who is AB congruent to? Well, right here. Position 1 to 2 is EF. And then we can go position 2 to 3, which is BC, side BC. And 2 to 3 on the other one is side FG. And then 3 to 4 is CD, side CD. And 3 to 4 here is side GH. And finally, if we go from 4 back to 1, all right, I'll mark that one, 4 back to 1, because we have to connect the ends of do our final side on our polygon here, AD, and 4 back to 1 is HE. Now this works for your angles as well. So angles in position 1, now a little trick I'm going to use here is on small diagrams like this, you can see already that if we start marking everything up, it's going to get really messy. I've told you many times that geometry is easier in color. Well, this is where it comes in handy. So I am going to look in position 1, and I know that angle A, which I'm just going to put a purple dot on, is congruent to angle E, which I'm going to put a purple dot on. And then position 2 is angle B and angle F. And you see how that identifies them but doesn't make it so messy. And then position 3 here is C and G, and position 4 here is angle D and angle H. So you can see how using color can be really helpful. This is also why we redraw, so we can draw our diagram larger so that we can see all of our markings and make everything clear. And drawing and labeling is your friend. You must draw and label, especially label, everything that we're going to do. Those of you that have already been doing it, you are going to be fine. Those of you that haven't, well, you're going to have to now. There's no choice any longer. Let's look at a problem here. We are told that quadrilateral HIJK is congruent to quadrilateral LMNO, and we want to know what the corresponding parts are. So I am going to 1, 2, 3, 4, 1, 2, 3, 4. I'm going to go over here and mark my diagram. So my first side, HI and LM are congruent, and IJ and MN are congruent, and JK and NO are congruent, and 4 back to 1 is KH and OL are congruent, and then I'm going to mark my corresponding angles, H and L and I and M and J and N and K and O. And so now you can see which sides are congruent, are corresponding and congruent, which angles are corresponding and congruent. Our first example up top was a flip. This one is a flip and a rotate. So you can see how this can be difficult to see if everything's not marked properly. And geometry is so much easier in color. All right, so you see how this works. Go ahead and pause the video and you try the example problem. You can see that there is no diagram drawn for you. You don't need one to do this, but at this point it might be easier if you just sketch a quick diagram, a couple of quick triangles, label them, and mark your corresponding parts. So, see you in a minute. All right, you should have gotten these corresponding sides and angles, and yes, they must be in this order. You could go in the opposite order, but both of them must be in the opposite order. I know that we have said before that segment WY is exactly the same segment as segment YW, but when we are comparing congruent figures, congruent polygons, order matters. So you could have done this without drawing a diagram and labeling it, because you know position 1 matches up with position 1, and position 2 corresponds with position 2, and position 3 corresponds with position 3. But if you needed to, drawing a diagram and labeling is very helpful. All right, let's look at an example of using our corresponding parts. So we are told that the wings of an SR-71 Blackbird, like one of my all-time favorite airplanes, are congruent triangles, which makes sense because aerodynamics is really helped out by congruent wings. You like your wings to be the same to fly. So we could say that triangle, now it doesn't matter how you name the first triangle here, but good choices make things easier, and we'll talk about that in a minute. So I'm going to name triangle ABC is congruent to triangle. Now where did I start? I started over here on the outside tip of my wing, so that's where I'm going to start on this one, D, and I went up to the top here toward the front, so E, and then back down to the bottom inside like that. So there's my triangles. Now we want to know what is the measure of angle D. I am interested in the measure of that angle right there. Now I don't have enough information about that triangle to find that angle, but I have information about the congruent triangle over here. So I would use the triangle angle sum theorem, yay, to find the measure of angle A. And we find that the measure of angle A is 75 degrees. So I would label that 75 degrees. Now, if we look at our two triangles here, we know that angle A is in a corresponding position to angle D. So we can say that angle A is congruent to angle D. That's just definition of congruent triangles, congruent polygons. And then we know that if our angles are congruent, the measure of angle DA is equal to the measure of angle D. That's just definition of congruence. And so we can just substitute in, and we know that angle D is also 75 degrees. So that was easy. All right, we have another example for you, another problem for you to try here. Again, there are no diagrams. I would probably recommend drawing diagrams and labeling them. So good luck on that. Give it a shot. Okay, so you should have drawn your diagrams, labeled them, labeled your congruence statement, 1, 2, 3, 1, 2, 3, and so you know two of the angles of the first triangle. Use the triangle angle sum theorem to find that angle S measures 83 degrees, and then we know that angle S is congruent to angle V, right? Angle S right there is congruent to angle V just by definition of congruent polygons or congruent triangles, whichever you like. And if our angles are congruent, then we know our measures are equal. That's the definition of congruence. So we can just simply substitute in. This is just substitution. Substitution property. And we know that the angle V measures 83 degrees. We could also very easily say, because M and W are corresponding and congruent, we put in 62 degrees there. K and Y are corresponding and congruent, so this would measure 35. Because our corresponding triangles, our congruent triangles, have congruent corresponding parts. Okay, that was fun. We can also use this to find congruent polygons. So let's look at what we are given here. We want to know if the triangles are congruent. Well, let's look. we can see here that segment AB and segment ED are congruent. That's given to us. That is just marked, right? If there's markings on the diagram, that is just as good as being written in your given statement. Those are given to us. And if we look here, we see that side BC measures 4 units, side DC measures 4 units. So this is given to us that our measures are 4, and this is just definition of congruence. We can say that the sides are congruent because their measures are equal. And if you look here, side EC and side AC, for the very same reason, those lengths are given. We have equal lengths, so by definition of congruence, we have congruent sides. Okay, and what else are we given? We have angle A and angle E are congruent, and angle B and angle D are congruent. That is given to us. And if you look right here in the middle, it should have been one of the first things that jumped out at you. We have vertical angles. Vertical angle theorem. Those two angles are congruent. Now look at how the angle's written. Angle BCA is congruent to angle DCE. Can you see why it has to go in that order? Because all of our corresponding parts have to match up. So we can use this to write a congruence statement. And look at where we start here. Triangle ABC. So we now have position 1, 2, 3. It doesn't matter what order you write the first figure in, but making good choices will make it easier to write the name of the second figure. So take a look here. Look at vertice A. It is the angle mark 1. Vertice B is the angle mark 2, right? It's got 2 congruent marks. And vertice C has 3 congruent marks. So when we go over to the other triangle, we know that we need to go 1, 2, 3. So it is congruent to triangle EDC. And that's just definition of congruent figures. Definition of congruent triangles. We have 3 corresponding congruent sides and 3 corresponding congruent angles. So we have 3 corresponding congruent sides and 3 corresponding congruent angles. So everybody's in the proper position and everybody is congruent. We have congruent triangles. So go ahead and see if you could answer the next question. Okay, you should have seen that you were given 2 sides, side AD and side CD. And then you can get a second side using the reflexive property of congruence. If you separate your triangles over here, you can see that side DB is side DB. And you now have 2 sides, but that's all the further we can go. So there's only 2 sides and no angles whatsoever. So no, we can't say that those triangles are congruent. Let's do our theorem for this section. This theorem uses the triangle angle sum theorem to prove, as its proof. So this one will be fun. Our theorem is called the third angles theorem. We can shorten that to third angles theorem. And let's see what it says. it says if two angles in one triangle are congruent to two angles in another triangle, so let's go see what our requirement is. We have two triangles here, and we are told that angle A is congruent to angle D, and angle B is congruent to angle E. So we have two triangles, and two angles in those triangles are already congruent. Then what's the result? The third angles are congruent. Now, how does this work? Well, I told you that it's triangle angle sum theorem, so let's look at our first triangle here. We can say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That's triangle angle sum theorem. And in our second triangle, we can say the measure of angle D plus the measure of angle E plus the measure of angle F equals 180 degrees. That's also triangle angle sum theorem. So look here what we've got. I know that angle A is congruent to angle D and angle B is congruent to angle E. So that lets me say the measure of angle A equals the measure of angle D, and the measure of angle B equals the measure of angle E. That's just definition of congruence. So I can say those measures are equal. So what is that going to leave? That's going to leave the measure of angle C, little substitution here, because we've got both of these right here, equals the measure of angle F. And if my measures are equal, I can say angle C is congruent to angle F by definition of congruence, right? Equal measures means congruent angles. So let's take a look at our proof here. Well, actually, first, let's do this with numbers. Sometimes if you're having difficulty seeing, you can just put numbers in and it makes it easier. If I told you angle A measured 40 degrees, what else could you tell me? You could tell me angle D also measures 40 degrees. They're congruent. They have equal measure. And then I tell you angle B measures 60 degrees. So you can say, well, I can go over here and automatically mark angle E 60 degrees because they are congruent. Now, if we use the triangle angle sum theorem on our first triangle here, we know that angle C has to measure 80 degrees. And if I do the triangle angle sum theorem on the second triangle, angle F has to measure 80 degrees. Right? Triangles have to, the measures of the angles of a triangle must add up to 180. So the measures of my angles are equal, my angles are congruent. So let's look this over in our proof here. We are given that our angles are congruent. This is just definition of congruence, makes our measures equal. And then we use our triangle angle sum theorem here, sets them equal to 80 degrees. And then because we've got this going on, I can just set them equal to each other. And we're going to cross out A and D and B and E. And we're left with the measure of angle C equals the measure of angle F, which means that our angles are congruent by the definition of congruence. So that's the proof that we just did up above. So it's all good. Pretty simple proof there. All right, let's look at our last example here. And we are given lots of things. So we look at our diagram. We are given lots of things on our diagram, and I am going to redraw my triangles so that I can see them a little better. And this is L, M, N, and L, O, N. Okay, and let's go mark what we know. We know LM is congruent to LO, and MN is congruent to NO. Now, can we get 3 sides? We need all 3 sides to be congruent. Well, look right here. This is something you need to be actively looking for. This is the reflexive property of congruence. Ln is Ln. So, along with vertical angles and linear pairs, you now need to be actively looking for reflexive property. So, I now have my 3 corresponding congruent sides. All right, let's go to the angles. So, I know that angle M and angle O are congruent. I'm given that. And I know that angle L and angle L are congruent. MLN and OLN are congruent. I need a third angle. How on earth am I ever going to get that third angle? Well, we have a theorem that says if 2 angles in 2 triangles are congruent, then our third angle is congruent. So that's our third angles theorem. We now have 3 corresponding sides, congruent sides, and 3 corresponding congruent angles. We have everything we need. So how are we going to write our congruence statement? How did I tell you? Oh, I marked these backwards. Now everybody's gone. There we go. These were marked with 1. These are marked with 2. All right, how did I tell you was the easiest way to write your congruence statement? You can start at any vertice and go in any order, as long as you don't lift your pencil. You just go around the figure. I am going to say that triangle, where would I start? M, and then I would go to L, and then I would go to N. Why did I go in that order? Because there's 1 congruent mark there, 2 congruent marks there, and 3 congruent marks there. And I do that so that when I look at my other triangle, I go, oh, well, that's just OLN. Because it goes 1, 2, 3. So let's look at our proof and see how they did it. All right, here are 2 sides that were given. And here is our third side that uses the reflexive property of congruence. Here are 2 angles that are given. And here is our third angle using the third angles theorem. And then here is our congruence statement that is simply by the definition of congruent polygons or definition of congruent triangles, because I have 3 corresponding congruent sides and 3 corresponding congruent angles. Now notice their congruent statement is in a different order, but notice that the positions match up. In mine, M and O match, and there's M and O match. In mine, L and L match, and there's L and L match. And in mine, N and N match, and in theirs, N and N match. So this is the same congruent statement, even though it is different. Making good choices on your first polygon will make everything go very smoothly. I think you are going to have a lot of fun with congruent figures. So go and enjoy your homework.